In episode 1, we started with an unknown sample that we ran through File Analyzer and got our first look at the file hashes, entropy, and PE metadata. We used malhash to check the SHA-256 hash against VirusTotal and MalwareBazaar and confirmed we were dealing with a known RedLine info stealer. Today we go deeper. We're going to extract the strings, read what they tell us, map them to attacker behaviors, and use that knowledge to write our own detection rule. mStrings is MalChela's string extraction engine. It goes beyond the classic strings utility by running every extracted string through a detection rule set and a MITRE ATT&CK mapping layer simultaneously. The result is a report that doesn't just list what the file contains, it tells you what those strings mean. Let's run mStrings against the sample we were working with earlier. "62 detections. That's a busy file. Let me walk you through the categories of what we're seeing so you can start reading this output the way an analyst does. This is gold. A PDB path is a compiler artifact, a leftover breadcrumb from the developer's build environment. This one tells us the malware was packaged as a self-extracting WinRAR archive, built on a machine whose project directory was WinRAR/SFX. The malware author forgot to strip out this debug information. From an IOC standpoint, this string is extremely specific. If you see it in another sample or a memory dump, you can be highly confident you're looking at the same builder. These random-looking names are the names the dropper uses for executables it writes to disk. They look random, but they're not. These file names are hard-coded in the sample. That actually makes them better IOCs than they look. A truly randomized file name gives you a behavioral pattern to hunt. A hard-coded file name gives you a literal string to match. If you see either of these names appear on a host, you're not chasing a family trait, you're looking at that specific build. That's a higher confidence hit. WMI queries like this are textbook system enumeration. The malware is fingerprinting the host, OS version, hardware, likely to check whether it's running in a sandbox or on a real target. This maps to MITRE T1047 Windows Management Instrumentation. Beneath that, we see Windows Data Protection API calls. DP API is what browsers and credential stores use to protect safe passwords. RedLine is an info stealer. This is the core of what it does. T1027 obfuscated files or information, but the operational significance is credential harvesting. We also see several checks by the malware to check if it's running in a debug environment. The malware asks Windows whether a debugger is attached. If yes, it likely exits and behaves differently. The timing-based checks using Query Performance Counter are a subtler sandbox evasion. The malware measures timing to detect an artificial environment. File mapping followed by map view of file and create thread is a classic injection setup. The malware can map code into memory and execute it in a new thread, detaching the payload from the original file. The WinRAR SFX archive drops and runs a batch script. This is the installation choreographer. It likely handles file placement, registry writes, and cleanup. Taken together, what we're looking at is a fully featured info stealer with credential harvesting, host fingerprinting, anti-analysis, injection capability, and an installer. The strings alone tell us a very detailed story. A few things worth calling out here. First, the tactics column maps each detection to MITRE ATT&CK tactic. Defense evasion, discovery, collection, execution, etc. This is how you start reading a file not as a collection of strings, but as a collection of attacker decisions. Second, and this is important for anyone who wants to extend MalChela, those detections come from detections.yaml, and that file is editable. If a detection is too noisy or isn't working for your environment, you can edit or remove it. If you want to add your own detections, just follow the YAML format of the existing rules and assign the appropriate MITRE mapping. If you create a detection worth sharing, submit a PR and we can add it to MalChela. The detection logic is a community extensible by design. If you want to learn more about a particular tactic or technique, MalChela includes a MITRE lookup utility. In this case, we'll use one from our example, T1574.001. Now let's string together a few more utilities and create a detection rule for this sample. If we scroll to the bottom of our results, we see a list of potential file system IOCs. We're going to copy them and add them to the Scratchpad. While we're here, let's grab the file hash as well. We'll add that to the Scratchpad, prefacing it with hash. From here, we'll move to strings to YARA. We'll give our rule a name, a description, an author. If we go back to our Scratchpad, we can capture the hash. And then in this case, for the string source, I'm going to tell it use Scratchpad. It'll import what we had in the Scratchpad file. And when we click run, there we have our fully generated YARA rule for those particular strings. To access that YARA rule, we can go to View Reports, look under Strings to YARA, and here we have our YARA file. Strings to YARA takes the list of strings and produces a YARA rule with proper structure, a metadata block, a strings block, and a condition. One thing I want to be direct about here. This output is a starting point. It is not always a finished rule. Strings to YARA does the scaffolding. Your job as the analyst is to evaluate the strings, tighten the condition logic, and decide how confident you need to be before this rule fires. In this case, we have to update the string for the PDB detections, as the special characters of the backslash need to be escaped. With that, we can save our rule. I'm going to go back to our file analyzer results from the previous episode. If you look at the last line, we see it says no YARA matches. If we copy our YARA rule from the saved output and put it into the root YARA rules directory in the MalChela folder, in this case I've renamed it to redline.yar, the next time we run File Analyzer against this sample, or another sample with matching strings, we'll see we've now got a YARA match included within File Analyzer. That's it for today's episode. Come back next time, where we'll look at integrating MalChela into the Remnux malware analysis distribution.